Hello and welcome to our demonstration. Special thanks to Tom Lumia, the SunView software team, and Dr. Kenneth Christensen for all the help during the semester. The agenda for the day is the following: background, problem, requirements, test plan and demonstration, design, summary, and lastly, future work.
Starting off with background, SunView Software is a leading provider of IT service management software that helps companies build smarter, more responsive IT services environments. The main line of software they develop is the ChangeGear products. These deliver intelligent, people-centric IT service management that ensure customer solutions meet their current and future business requirements. ChangeGear consists of the Change Manager software, Service Desk, and Service Manager. However, currently there is a need for superhuman support. This kind of support is explained in a blog post by the SunView team, where they quoted a nuanced communication study which said that 89% of consumers want virtual assistants to have the computational power of a search engine, but they also want conversations with this technology to be more casual and colloquial. This calls for the need for an automated chatbot. An automated chatbot is a computer program that simulates the conversation of a human being via text or voice interactions. A user can ask a question or make a command, and the chatbot will respond or perform the requested action. These chatbots are implemented through machine learning, which is programming a system to learn from and make predictions based on data. Given a large dataset, a machine learning bot can become quite adept at understanding the user's intent. Text classification also makes it simpler to understand user input intent by systematically tagging or categorizing a text input with most important key phrases. By using these two technologies, it is possible to configure a chatbot to provide an appropriate response. The problem that we're dealing with is, can machine learning techniques be used to implement a chatbot capable of using text classification to correctly categorize a query, which is a one-sentence user input in English, into one of 24 different categories of technical or non-technical queries with at least 75% accuracy?
The requirements are as follows. 1. The bot must be able to correctly categorize user input into one of 24 possible tags with at least 75% accuracy after asking for clarification. 2. When confidence for text classification is between 20 and 60%, the bot should ask the user to clarify the query. 2.1. If the bot is still below 60% confidence after checking the new query, it should return a message redirecting to a general FAQ page or customer service representative. 3. When confidence for text classification is below 20%, the bot should return a message redirecting to a general FAQ page or customer service representative without asking for clarification. 4. The bot should function with a non-graphical UI. 5. The bot should not affect its environment's computing abilities. It should be able to efficiently and completely run without slowing down or limiting ChangeGear's functionality. 6. The bot should take less than 5 seconds to produce a response to each query, assuming the presence of a good and stable computing environment.
To demonstrate the bot's functionality, we built a dataset of 100 queries per bucket, or 2,400 total. We randomized the set and split it into 4 quarters of 600 queries each. We then trained each quarter against the other 3. This is the exhaustive cross-validation method. We also asked real people to try out the bot with prompts of their own. This is what the data looks like. It's a label prefix, then the label itself, and then the query. This is a visualization of the cross-validation method. We have a complete training set made up of 4 quarters, A, B, C, and D. And for each quarter, we remove it from the set, so that's 600 queries being taken out, leaving 1,800 others. We test the 600 queries against the 1,800 that are remaining.
So the next thing that we want to do here is actually demonstrate how the partition works. We're going to go ahead and actually train our model with group A of data. At the same time, we're going to be testing our model with a group A of testing data and not training data, as on the first case. We can see this is the actual file we have for training data, which is a different file than the one we have for testing data. We then jump into our terminal. We run our model. Once the model is created, we run the driver or the file that's actually utilizing the model. We go ahead and we see how we have an accuracy of barely 92% using 600 examples. That 600 number comes from the fact that we're using 25 queries for each one of the 24 buckets. So once you multiply 25 times 24, that's how you reach that number of examples. And the accuracy is calculated using something called the F-score, which is widely accepted measure, a statistical measure used for accuracy. So following what we have demonstrated for group A, we can now clearly see how for group B the accuracy is of 94.33%. For group C it is of 92.33%. And finally for group D it is of 92.83%. As we can see, this is greater than 75% in all of 4 cases, so this satisfies requirement number 1.
We are now going to test the bot with respect to the remaining requirements. Suppose we have a user that doesn't really want to use the bot for its purpose, so they ask a gibberish question like, "Where is my dragon?" The bot produces a low confidence level, only 34%, because that's not what the bot was built for. So it asks the user for clarification. This fulfills requirement 2. Let's say we have a stubborn client who doesn't really want to rephrase his question, so the same question is given. Where is my dragon? Obviously, this is going to produce the same exact confidence level as it did before. So the bot is still below the 60% confidence threshold after being asked for clarification. So it boots the user out and redirects them to a customer service rep. That fulfills requirement 2.1. Next, we're going to test requirement 3. Suppose that the query is such nonsense that not even a human could understand it. So for example, who, what, where, why, how, be, think. That is a complete nonsense query. The bot has no idea what's going on. It has a confidence level of 12%, well below the 20% threshold for requirement 3. So the bot returns a message redirecting the user to a customer service rep without asking for clarification. It is self-evident that the bot runs on a non-graphical UI, filling requirement 4, and it is also apparent that the bot takes way less than 5 seconds to produce a categorization, which fulfills requirement 6. In order to prove that we've fulfilled requirement 5, the bot should not affect its environment's computing abilities. We're going to do some high-intensity stuff. We're going to train 2 discrete models of 2,400 queries each for 4,800 models total. So by running chatbot2level.py, we are training the model, and you see that it happens in below half a second. Based on the number of queries that were categorized in that little time, there's little cause to believe that this would be a resource hog on a server-grade computer. The bot is also below 8 megabytes in size, so it's not a resource hog at all.
So the 4 randomly selected forms that we use from the 11 that we collected from the engineering students are Jonathan Manigo, Itze Kenny, Corey Floyd, and Osniel Quintana. Okay, so starting up we have Jonathan. Jonathan's first question was, how are you? As you can see, the bot predicted correctly for it to be greens and gave an appropriate response. Next up from Jonathan we have, this website is not letting me access it. As you can see, the bot is asking for clarification right now, and we can rephrase this query to be, I cannot access this website. Here we can see that we actually got the prediction from the bot, and he redirected to an FAQ page about a website. Jonathan's third question was, how do I recover a file that I've deleted? And we can see that we got the bucket predictions for it to be files, and it redirected to a FAQ page for files. Okay, so next up we have Itze. Itze's first question was, how many vacation days do I get a year? And we can see that was tagged as holidays, which is great. The second question was, what is the origins of Halloween? And we can see how that got categorized into the Halloween bucket, which is great as well. And for the third question we have, how can I unblock block websites? And we can see that we got the website bucket for that one. So this particular test went great. Next up we have Corey Floyd. Corey, his first question was holidays per year, and this bucket was categorized as holidays, which is the correct intention. The second question from Corey was, how do I connect a printer to my network? And we can see how that got selected to the printer bucket, which is exactly what Corey meant. And lastly, Corey asked, how do I defrag my HDD? We can see how the bot now is asking for clarification, and we can rewrite that query to something like hard drive defragmentation, and we can see how again the bot tried to classify it but didn't get enough information, so it actually terminated. Lastly, we have Osniel Quintana. Osniel's first question was, hey, how is that going? And we can see how that got sorted into the greetings bucket, which is exactly what he meant. Next up, for the second query, we have what does SunView sells, and that is actually being sorted into the SunView bucket, which is great as well. And lastly, for Osniel, we have where did my files go, which is sorted into the files bucket. However, it doesn't have that much of a confidence, so we ask for clarification, and rewarding his query, we can have I cannot find my lost files, and that is actually sorted into the files bucket, which is what we wanted.
We will now proceed with the in-person demonstrations.
Alright, so we have a machine learning chatbot here. It's trained in these 24 topics. We need you to ask a one-sentence query that you think will be categorized into one of these topics, and we're going to see if the bot categorized your question correctly.
Okay. So my questions could be like anything.
Anything you think will fit in one of those buckets. So for example, if you said hello, that should fall under greetings.
Okay. All right.
Give it a shot.
Okay. Dressed up as a Cheba. If you wish to know more about Halloween, it definitely knew Halloween.
Yes, it predicted Halloween. You can go to a next query.
Okay, so I can type in any query I want now?
Yes.
Okay, cool. Let's see. My computer is not working. And keeps turning off. So there's a frequent help, yeah, for a computer. So it seems to do that.
All right, that's good. That's good. So if you wanna give it another try,
Right.
with a different one.
Right. Okay. Let's see here. I lost a file and need to retrieve it. If I spelled retrieve right.
All right.
And I actually think I spelled it wrong.
So do you think your intentions were matched by what you saw in the bot? The answers were correct.
Yeah.
All right. We appreciate your time. Thank you so much for your help.
Yeah. No problem.
Hey guys, this is Professor Katkuri, the graded guru of CMOS VLSI, who gave you so many sleepless nights. So today I'm the guinea pig here. I have to test the chatbot program. I'm sure it'll work because it's all designed by computer engineering students. Alright, so let's try the first one, which is hello, how are you? Greetings. Okay. My internet is very slow. Okay, and let's see. Oh no, I deleted my most important passwords file.
Okay, so now that you tested 3 questions, do you believe that the questions that you asked the chatbot and that the chatbot responded with its prediction, do you believe those were your original intentions?
Yeah, that is correct. So first one was greetings, which it did correctly. Second was internet, so that's internet troubleshoot, right?
Mm-hmm.
So that is good. And then third is the file recovery, so it did file recovery. So yeah, it sounds great. So looks like it's ready to go into the world, into the real world.
Thank you very much.
Thank you,
Thank you
Professor.
so much for your time.
Take care.
In terms of design, we use FastText as our test classification service. FastText takes the training data that we generated, in this case our 2400 queries, and generates a trained model that we use for our chatbot. Our chatbot receives an input query from the user. Such input is processed by the trained model previously generated by FastText. The bot will then try to classify the query into one of the 24 buckets. If it does so with a confidence of less than 20%, the program terminates. If the query is classified with a confidence of 60% or higher, it gets assigned to its respective bucket. If the query is classified with a confidence level between 20 and 60%, the bot will ask for clarification. If the new query can be classified with a confidence greater than 60%, it is assigned to its respective bucket. Otherwise, the program terminates. We decided to use FastX over other services like Azure and TensorFlow because it has all the characteristics that we were looking for. The main points of comparison are that FastX allows you to export the created model, which Azure does not, and that it is not a resource hog in contrast to TensorFlow, which has been reviewed and criticized for trying to take as much from the UPU as possible. In summary, we were able to create a chatbot capable of using text classification to accurately categorize a query into one of 24 buckets with about 90% accuracy. The bot is also capable of asking for clarification, is computationally inexpensive, and faster than any human respondent.
In terms of future work, the training data could be customized by the customer to meet their specific demands. In order to further improve classification, more training data could be added. There's an option of an output text file that adds all queries under 60% to the training set, and also, if requested by the customer, a GUI could be implemented. Thank you for your time. Any questions?